This is a summary of the bookwork. We are to summarize 24.1 and 24.2 and do questions 1 through 8. What we have here is we have the chapter on thermodynamics, which is basically just heat flow. The first one, absolute zero, the most important thing about that is that 0 Kelvin is the bottom temperature, and that's where the energy is 0. And so ice is not where energy is 0. Ice is way up here, and there's lots of energy in ice. So that's the big misnomer about the Celsius system. Absolute zero is the place where there is no energy. And so that would be low heat, low energy, low temperature. And this would not be so much. Of course, it goes up and up and up as it goes through. So that's the first thing about absolute zero. The second thing is you need to know that Celsius and Kelvins are the same size unit. Okay, moving on to the first law of thermodynamics. Basically, we're saying that we can follow the direction of heat flow. So as we go through here, we talked about the first law of thermodynamics being similar to the law of conservation of energy, that we can energy can either be created or destroyed. It just changes forms. And so here the book has it like this: Q is equal to U plus W, which is basically the same idea as U equals Q plus W. Don't worry about the signs too much, because the signs in here, you need to imply that when energy goes in or out, that determines the sign. So you do have to worry about the signs, but don't consider it too much in the relationship here. This is the form we use it in class. So use it in that sign, use it how we do. And then if the energy goes in or out, it's either positive or negative. So energy in is positive, energy out is negative. Energy in is positive, energy out is negative. And then, of course, there are questions 1 through 8, which we covered in class. Questions 1 through 8, we covered these in class. Thermodynamics, the movement of heat. Microscopic, because we're dealing with molecules. 0 on the Kelvin scale is absolute zero, and this is negative 273 degrees Celsius. Melting ice is 0 Celsius, that's 273 kelvins. And boiling water is 100 Celsius, that's 373 kelvins. Law of conservation of energy and the first law of thermodynamics are the same, basically. We're following energy. We can say where it goes. So that's the internal energy, that's heat, and that's work. Energy can neither be created nor destroyed. It can only change its forms, and these are the forms that we talk about. All of these are talking about kind of like adiabatic processes. And if you take, let's say, air, and we capture it inside of a tube, if you were to squeeze in on that tube, you would be doing work on that tube, and the energy on the inside would either increase or decrease depending on if you squeezed in or if you let go. If you let go, it's going to pop back out. So that's kind of that adiabatic process. And when we squeeze the gases on the inside of an engine, typically we squeeze it down, compress it, raise the energy, light it on fire, it explodes and pushes back out and does the work that we want it to do for our heat engine. And we'll talk more about heat engines in the next section.